Hello, I'm Charlie Knott, a Senior Director at RTI International. I'm presenting today on behalf of our team that consists of survey methodologists, data architects, system programmers, and analysts. Today we're going to present an overview of the AURORA study. That's a longitudinal study. It's multimodal, looking at brain biology and function after traumatic stress exposure. We are combining various sources of big data with survey data to paint a complete biobehavioral picture of trauma patients. We will cover these 5 areas in this session. Starting in emergency departments and incorporating diverse, broad, and separate big data streams. This presents technical operation and logistical challenges, but allows for a greater scientific understanding of the long-term effects of trauma. We're going to outline key data-driven system challenges and solutions and investigate eligibility considerations and compliance outcomes, incorporating multiple big data measures using an integrated data-driven system architecture. AURORA is a cooperative agreement utilizing over 60 subcontractors, including 30 to 35 emergency departments as the recruiting sites. Dr. Sam McLean, the University of North Carolina at Chapel Hill, is an emergency room physician and is the contact PI. Trauma survivors aged 18 to 75 are enrolled through these emergency departments in the immediate aftermath of the trauma. Over the following year, participants engage in a state-of-the-art series of assessments. Data collection includes web-based surveys, neurocognitive assessments, ecological monitoring via a smartphone app and via the Study Watch, biospecimens, and for a subsample, in-person deep phenotyping assessments, which includes functional magnetic resonance imaging. A maximum of 1,250 separate data collection events and reminders are currently scheduled for each participant over the study year. That is dependent upon their cohort assignment and various adapted sampling algorithms. This slide presents a representation of the data assessments that occur over the longitudinal 1-year study period. Starting in the left-hand corner and proceeding clockwise, let's go through the assessments and the types. We have the digital phenotyping via flash surveys where participants use their own smartphone via the MindStrong Discovery app. Next to that is the Verily Study Watch, wearable technology. We then have self-report surveys, neurocognitive assessments using Test My Brain web-based technology. We do various brain imaging and functional MRI. We have audio recordings and then sources of DNA and RNA and plasma. In totality, RTI's information management system electronically controls these 1,250 data collection events and reminders, and that is per participant. Obviously, the amount of data that we're generating across participant grows dramatically every single day. In this slide, we outline the complex prospective data collection schema using phenotypic variables, ecological monitoring, physiologic, biologic, neurocognitive, symptom, and health outcome assessments across multiple time points over the 1-year participation period. This table incorporates multiple external sources of big data generation and associated intellectual property and patents. The first column on the left lists the 10 separate assessment types. The rest of the columns depict when data collection events occur over the year period. So the little legend at the bottom, ED, means it happens at the emergency department. W stands for weekly, and there's 6 separate periods. M stands for monthly, of which there are 4 periods. And the 1 signifies an adaptive sampling schema. So various cohorts and other paths in the protocol implement adaptive scheming platforms. This figure shows a concatenated flowchart combining all steps and hundreds of pages of consent, scripts, questions, apps, external system instructions and credentials, as well as study website usage into our single-use baseline program that encompasses the 3-hour-long baseline data collection effort. The steps are listed in the blue shaded boxes, while the data outcomes generated from each step are immediately available for adapted sampling or launching big data app or subsequent data collection events. This enabled ED nurses and research coordinators to perform electronic baseline data collection on iPads via encrypted Wi-Fi technologies. An interesting tidbit is that in the entire 3-hour session, The only paper that exists in the year-long protocol per participant is the consent form. All of the remaining 1,249 data collection event and reminders are electronic. Given the intensity of data collection over the year-long period, AURORA is designed with numerous eligibility criteria embedded into the electronic screener. So this graph, the y-axis represents percent eligibility, while the x-axis divides the cohort by sex and age into 6 categories for comparison purposes. The percentages within each sex and age stratum total 100%. So let's talk about the results. 16% of the eligibility criteria are related to big data exclusion items. That's 7 of the 45 ineligibility factors. That's represented by the solid red line. Non-big data exclusion criteria account for the majority of ineligibility, and that's listed by the dotted red line at the top. On average and by design, only 19% of the ED screen population is eligible, which is designated by the blue solid line. What this graph shows is that women are more eligible than men, and the older age group, as expected, are less likely to have and or use a smartphone or have an email address. There's a lot going on in this slide, so let's review. The small graph at the top reminds us of the 7 big data and eligibility criteria from the previous slide. Just looking across, its average is about 14%. However, when you break out by an eligibility criteria, there's a wide variety of variation. So let's look at the ineligibility results. The study watch is represented by the blue dotted line refusal, which is very small, about 2%, while sensor allergy to nickel, a component of the study watch, which is represented by the black dotted line, is higher for women at about 10% and less than half of that for men. On the smartphone side, the results sort of split into 2 different camps. Higher ineligibility for the lack of a device or will not use for the study, see the green line, and ownership duration, which is represented by the purple line. To be eligible, people had to have a phone for over a year. Lower ineligibility is for physical impairment, which is represented by the yellow line, and refusals, which is represented by the orange line, which is very much lower. Obviously, the no email address was more of an issue for the older age groups per the previous slide. For each source of big data, we present a circle or a watch face analogy. The first half hour shows the device technology, while the latter half hour shows how we operationalize it into our protocol. As mentioned already, we use the Verily Life Sciences as the study watch. This watch is provided to participants at the time of enrollment in the emergency department. It captures continuous 3-dimensional accelerometry, skin conductance, and environmental factors including temperature, humidity, and atmosphere air pressure, and ambient light. It also carried out on-demand electrocardiograms at various time points. We have de-identified and encrypted data were transmitted from the participant to the study team via 3G or 4G charge and hub, and that's also provided to study participants. An interesting factor is Verily couldn't provide 5,000 study watches simultaneously, so each watch is spread out over multiple participants during the 4-year recruitment period. So the study protocol side, the second half hour, participants are instructed to wear the watch for at least 21 hours a day, and they are incentivized when they wear it at least 18 hours a day and sync it up into our database. So that's an interesting dynamic. We originally started with 154 events, but we extended that to 363 days of watch wearing in the latter parts of the protocol. Now that we've seen the Verily study watch, the technology, what it measures, and how we've operationalized it into the study protocol, let's look at the results. So first of all, the figure shows the percent of completed study watch wearing days from September 2017 through February of this year, 2020. We considered all participants who reached these days and they had an open date occurred, they were still enrolled, and classified whether they completed that watch wearing day or not. So the results show that we have, in looking at over 500,000 observations already, the blue line shows a remarkably consistent rate of about 36% of the study watch wearing days being completed. So using the familiar watch or clock analogy, our second big source of data are the Test My Brains from the Mini Brains project out of Harvard. As a reminder, the first half hour is device technology, while the latter half shows how we operationalized it. So we use the Test My Brain platform to perform online cognitive tests. We call these NCAs, or Neurocognitive Assessments. An interesting thing is we use the PID, the participant ID number, but we added a pin to it, and so we could supplement a group number to it to randomize the sequence of batteries or neurocognitive assessments across the participants and their repeated measurements. NCAs measure brain function, including reaction time, learning, concentration, personality, and memory. So the study rotated these balancing batteries of NCAs across weeks 1 through 8, and then again at months 3, 6, 9, and 12 for the prospective follow-up. On the study protocol side, we had 13 neurocognitive assessments per participant. This was at the emergency department, day 2 post-enrollment, and then on a rotational assessment, as I mentioned. The NCAs take about 10 to 15 minutes to complete, depending on the battery, and participants receive $20 at the emergency department, and then $5 for each of the 12 subsequent NCAs. Now that we reviewed the Test My Brain neurocognitive assessments, let's talk about what the results show. Same general strategy as the previous results, September 27 up to 2020 of February, and again, whether they completed or not, graphed secularly. So the results show that we've had about 28,000 observations thus far over that time period, and the blue line shows the percent complete. 75%, that's held remarkably steady since enrollment began back in September 2017, and obviously much higher than the percent complete of study watch wearing. Our third source of external big data for AURORA concerns digital phenotyping via participants on smartphones. We use the MindStrong Discovery app, platform, and technology, and this is where we're measuring brain function using participants' smartphones. So what are flash surveys? They're brief, about 5 minutes long each, and they are used validated questions assessing paratraumatic ongoing and recovery time points secularly. The surveys examine concepts and constructs such as acute loss, depression, disorganization, self-regulation, panic attack, appetite disturbance, and sleep issues and problems. An interesting thing about this particular platform, the app collects information on the time and duration of phone calls, the time and number of texts sent and received, keystroke information, when swipes or taps are made on the phone, when Wi-Fi access is being used, a small percentage of the phone's GPS location, and the number of times a word in a text was used over a 24-hour period. So I want to be clear here, the app only collects the information that participants had consented to collect, never shares information with anyone not listed in their consent. It uses little battery and does not interfere with the phone performance. So let's talk about the study protocol, the operational side. So as you can see, we have about 85 flash surveys over the year, as previously mentioned, about 5 minutes each, and we have an incentive of 75 cents per completed flash survey. So let's look at digital phenotyping compliance and results using the same format as the previous 2 slides. So we're graphing secularly percent complete versus percent expired on the same time frame. So in reality, over 188,000 observations have been gathered to date, and the blue line showing about a 66% complete across the different flash surveys of the digital phenotyping. Here we're presenting a combined results of compliance across the 3 external sources of big data. We've had over 743,000 observations to date. So NCAs, neurocognitive assessments, are at the highest range of about 75% complete, followed by the flash surveys, roughly 66%, and then the study watch wearing days being dramatically lower at 36%. So in conclusion, AURORA, given the high demand and burden on participants, by design has high ineligibility. It's known, it's needed. You want people to do 1,250 events, they've got to be able and willing to put in the time and effort over the year period. However, very interesting and a little surprising, we had low tag to the 7 big data items, if you recall, about 14%, but high variability across the age and sex stratum. Obviously, the men were much less eligible than the females across all age categories. And then in reality, in this trauma population in U.S. emergency departments, only 14% refused or were ineligible due to the 7 big data exclusion criteria. An interesting tidbit, which was not expected, is that the study watch was much differential for the females with a 10% allergy to nickel versus the males. And then in reality, as the previous slide showed, the neurocognitive assessments, highest compliance, then Mindstrong, followed by the study watch. Thank you. I'd be happy to address questions during the session's Q&A period. Here's my contact information if you have questions now or post the conference. Thank you.